Yay. Okay. Hello, everyone. Um, After 35 minutes of technical difficulties, um, we are here and we're ready to do this. Hopefully, there's still people tuned in. Sorry that it took so long. I think I've downscaled my resolution output, so things should be good now. Um, yeah. So, hello. I'm Francisco. I make games and also things that aren't games but are sort of like games. Um, I uh, have some experience with using Godot, which is the tool I'm going to talk about today, and also with Unity and other tools too. But yeah, before I get started on what I'm going to talk about, let me just explain sort of like for context, this is part of the Babycastles Academy series. So every Sunday at 3 p.m., Babycastles is hosting an instructional or maybe sometimes like a jam or some sort of like educational slash like thing to come together and like learn and try and experiment things. Babycastles is a 501c3. They are an experimental art game space based out of Manhattan. They host events and will usually host events in real life, not so much these days. But these days we're trying to take things more online, and as part of that effort, we are doing this Babycastles Academy thing. But there's also a bunch of things that we're doing. There's like streams going on, especially on the weekends, but also just like all the time. There's like different like let's plays or people streaming music or what have you on the Babycastles channel. So please check it out. Yeah. So okay. Today we are going to talk about Godot, which is an open source 3D game engine. So the structure of this workshop is going to be about like 20 minutes of talking about Godot, and then the rest of it until like I guess until we reach, because we started like 30 minutes late, so I don't know how much time we're going to have, but it should be enough time for the coding a game, or more like making a game in Godot. Okay. Make this smaller. Okay. Yeah, so we'll see how far we get with the coding part because we started a little late, but I think it should be fine. So for context, my experience with Godot is I've made one video game with it, which is, I'll show you right now what it is. A little self-plug. This game took me like 4 months of like on and off work to make. It is like more complicated than it looks, but it's also like not that big of a project. Walk around and talk to people. So I have like basically under my belt, I have like one experience making a game with Godot. I've also made some like games of like comparable size in Unity, so like tiny games or like sort of like class project size games. And I've also made games with Pico 8 and then like fooled around with doing things with P5.js, and that's basically it. So that's just sort of so you know, I have opinions on Godot and Unity and video game tools, so just so you know where those opinions are coming from. Okay, so first let's talk about Godot. So Godot is a video game engine. I guess like the one-liner for it is that it's an open source 3D game engine. The first thing that you should know about Godot is that the pronunciation of it is like pretty heated. Since it's open source, like because of that, there's not like an official, or like along the same spirit, there's not like an official pronunciation. The original creator of Godot, which is, oh, I don't know, I wonder how risky it is to go on my Twitter like this. Is this guy, Juan Lianeski, and he's sort of synonymous with Godot. He started it and is like the core contributor to the engine. So like he'll tweet all the time about like progress updates. Right now he's working on like 3D graphics, like intense 3D graphics stuff. There's like a bunch of, so it's an open source project, so like there's a bunch of different core contributors, but he's sort of the main one. Godot has a sort of long history. It's been around since around like 2011, where it started, or sorry, 2001, where it started not at all as like a game engine, but more as like a bunch of different tools to do different things like with like UI, and then slowly over time it's just it's gone from like this to what it is today. It's pretty unrecognizable and remarkable. So it has like a history. Where it sits in sort of like the pantheon of video game tools is it's definitely trying to be like a Unity like or a competitor to Unity or an analog to Unity. I don't know if it's like, I mean, I guess it's competing. You can basically, it's a pretty powerful and robust game engine for making all sorts of games, from 2D games to 3D games. I will just clarify right now that I have zero experience doing 3D with Unity or Godot, so I don't know how good it is at 3D at all, but that's like one of its main marketing points, right? And that's sort of like what it's trying to be. It's trying to be, the most I can sum it up is that it's trying to be an open source Unity. And whether it's a good replacement for Unity is the question. And I have thoughts on that, but we'll get to that in a bit. So, oh no, I need to close this. Sorry. Okay. Okay, so what's next? Oh, geez. I totally lost my... Okay. So we are going to... Oh, my God. Sorry, I lost my place in my notes. Okay. The big selling point of Godot is that it's open source, right? It has a MIT license, which is like the most, oh man, I don't want to like say the wrong thing. I'm not like an open source expert at all, but it's like the most permissive license. So like this lets you use Godot engine for any purpose without being charged for it. You can change the engine itself, and the source is up and ready to view by the public. Here, maybe? I don't know, you can Google it. Yeah, but this is like the actual entire source of the engine. You can download it and compile it yourself, modify it in any way. Um, and you can also make games with it and make things with it and not have to uh, pay royalties or what have you. You can, it's a very permissive license. So like I think this is like the big thing that Godot has going for it, right? Because, and that's sort of like its whole deal is that it's open source, right? So you don't have to pay royalties. You don't have to worry about a company putting like gates on who can use their product, right? There's no like $100 entry fee like there is for like the Apple ecosystem, and you don't have to worry about that happening in the future because it's open source. Another thing about it being open source is that it informs the actual design of the tool. So the process for what features get added to Godot and like what the tool ends up being itself is it's super transparent, and it's very crowdsourced. So like they have online, they have the roadmap for what's going to happen in Godot. In the future, you can see all these are all the features that are planned, and then they have also like all the proposals for improving it. You can submit a proposal, and once it's submitted, people debate on like what are the best things to do. The core developers get together and talk about it and decide. But it's very much like wisdom of the masses, for better or for worse. Juan Linetsky has said that this guy, the lead developer for it, has said that he's, for a while now, he hasn't felt like he's really had any sort of creative control over where the project goes. Like he's just sort of at the whims of the anonymous mob of people. So that's interesting, right? That's like different from how like Unity is, how features come across in Unity, right? Instead of like instead of like a company or of people who are trying to make the best engine, but like are deciding what new features to add or what not to have. It's sort of like very much a very democratic process, for better or for worse. I'm going to take a break right now to double check that there's no technical difficulties because I'm nervous from 30-minute pause. 1 second. Okay, everything is looking good. Awesome. Okay, cool. Right, okay. Yeah, and so I might go past 5 p.m. too. That's, yeah, okay. Right, let's continue. One second. I'm realizing I'm blind to Twitch chat right now, so I should see what's up there. Yeah, so before I continue, please ask any questions in Twitch chat and I'll get to them. I was not paying attention to it until just now. So if you do have any questions, I don't see anything yet. So I'm sorry. But okay, let's continue. Okay. Okay, so another thing about Godot that's interesting is that it has a native language, GD script. So it's a pretty, in terms of like languages. It's a high level language. It's very scripty. It's more like Python than anything else. Actually, if I were to describe it, it's sort of like Python, but if Python was designed to be for video game development. So like the trade-off is that since it's high level and it's more of a scripting language, it's less safe and less performant. And also, since it's this new language, you have to learn this new language before you can use the engine. There are ways to use other languages like C# or what have you, but they're not like, it's sort of clunky, and I've heard there's issues with it. There's also, if you find that when you're if you are having trouble with performance, there is a way to write code in C++ and create modules in C++ for more performant code. So there's that. The other thing is, the last thing about GDScript is that Godot has a native IDE, so you can edit, as it's a pretty good code editor built into the engine, which is cool. Yeah, okay. So I'll just talk a little bit about some of the issues. The main issue with Godot is that it's not very mature, as in like it hasn't been around long enough for a lot of like the kinks to be ironed out yet. There's like many cases when I was working on that game last year that I was trying to do what is like a pretty standard thing, like for example, duplicate an object, and after like a few hours of searching and trying to figure out the way to do it, I'd get to like this thread like this where there's like a bug open where there's like an issue with the function, and after reading all this debate, there's like this message from Juan, who's like the lead developer, who's like, yeah, well, this function's actually like pretty hacky and generally not recommended, and like I wish we didn't have it, but I don't know. And so that's not a very satisfying answer, and that is something that happened to me like a dozen of times for a dozen of different things when I was working on that game. This is like in contrast to my experience with Unity, where like, you know, there's a ton of problems with it too, and there's like there's issues, but like a lot of times with Unity, when I have an issue and I want to do something, I can Google it, and there will be like some Stack Overflow thread that will have like the answer, like the recipe or like some solution to what I want. And Godot, just because like it's not as popular and hasn't been around for as long, it doesn't have the same like developed community. Like there's a lot more dead ends and like frustrations. Like another example was I spent like 50 plus hours trying to implement this a dialogue system for that game, and just because like there are no pre-packaged solutions for it yet, right? Like in Unity, I could use like Yarn Spinner or Ink or something that would let me not have to work implement my own dialogue system, but there isn't that community yet for Godot. Not to say that there isn't like a great community, like the people, like there's a Discord, people are great. It's just that it's not mature, and so there hasn't like been all that great stuff that has like developed around Unity or other more mature tools, like I guess Unreal. I don't know. I don't have experience in Unreal. Yeah, so basically, like I really like Godot. I like it. I think that like the design, it's pretty similar to Unity. There's some things that are different, right? There's like a native, the scripting language is more high level, which I prefer. You'll see that there's like this system of nodes and scenes that used to be, I thought, like way better than the way Unity does things until Unity introduced like nested prefabs recently, and so that sort of like has brought that to more like feature parity. But in general, like I think for making like a bigger project, I am worried about using Godot because there's like not as much of a community. But the thing is that like there's so much hope because the problems with Godot aren't like anything fundamental to its like design or to its context, right? It's just that it needs more time and love and like people to use it, right? It's like there's a lot like all the issues of like, you know, there's not enough plugins or community made assets around it, or like there's not enough solutions to like common problems. Like those are things that like could be hypothetically solved if there were just more people using it, right? Which is like the dream of open source. I think like once you reach a critical mass, things would just, you know, be better. Is the hope, at least. I don't know. But yeah. Anyway, now that I've finished trashing this tool, let's make something with it. I love this tool. There's some issues with it. Okay. Let's open. Let's do this. So now I'm gonna make something. So we'll make a very tiny, small game, and I already made this game in preparation for this workshop, but we're gonna remake it, and I'll pretend, or I'll try to like do it all from scratch and talk along my process. I was trying to talk to people who've used Godot or that are interested in it about like what are like the key things that they want to learn, and a lot of the feedback I got was that like the overall structure of how to structure and like design, implement a game in Godot is like sort of weird and confusing. So I'm going to focus on trying to explain how I like structure a game, and then I'm also going to focus on like the like my process for just like getting a working game together. This is like very much my way of doing things. So like there's probably other ways and better ways to do things, but maybe hopefully just by seeing how I do things, it'll I don't know, give you an idea of how to use this tool, or yeah, spark some good creativity, hopefully. Please ask questions. I tend to just kind of like ramble and do things, and also not be great at, like I'm not very good at being conscious of like what I'm communicating or not. So please let me know if you have any questions while I'm doing things. Okay. I'm going to check things yet again because I'm very paranoid. Before I start, I'm going to check the Twitch. Okay, cool. Looks like we're good. Cool. Okay. Okay, so wait, let me switch over to my notes for live coding. Come on. Haha. Switching over to live coding notes. Okay. Okay, so let's make a game. Whoops. Okay. So the game we're going to make is I've been spending a lot of time on my roof because it's one of the only places these days where I can just kind of like chill outside and tan, and not get like a face mask tan. And in my time spending on the roof, I've noticed there are a lot of birds around, and I was like sitting there and I was watching one of those birds, and I thought, what would it be like to be one of those birds? And so we are going to make a game where you're a bird flying across rooftops. So like the image that I have in my head is like we have this like side-scrolling bird guy. Birdie. And he's going, forever to the right. And he's like flying over like these buildings. And also there's like a blue sky. It's nice. So yeah. So I think first thing I'll do is I have this like image of what I want, and so I'm going to try to just like make it happen. That's sort of the idea in parts. Get this out of the way. Okay. Okay. Let's open up Godot for the first time. Hopefully this doesn't break my computer. Let's delete this. So this is Godot. I just downloaded the newest engine version, so it should be up to date. If you are opening this yourself, this will probably be empty here. But you can create a new project. The way that projects work in Godot is you have to choose an empty folder, and it'll create what's called like a project. I think it's a project.godot folder, or file, and that means that like is a Godot project folder. So we'll just call this bird game. Wait, no. Bird game here. Oh, geez. Bird game. Create the folder. So now we have this bird game. And then we will choose this option. So there's, I think that like for most cases, or like for tiny games like this, it doesn't really matter. But in general, this left option, the 3.0, is for like, big, impressive games with their like shadows and 3D and lighting things. It makes things that are like, it's good for games that are that need a high visual quality. But the downsides to it is that it's not compatible with like older hardware and not great for web. And since I am going to make a very small game, I'd rather it be more compatible hardware and better for web games. So I'm just going to choose this one. Okay. Okay, so the first thing we see is this is an editor, and if you're familiar with Unity, it's very similar in certain ways. Here it's prompting us to create our first node. I'll explain what that is in a second. But since I'm imagining a 2D game, I'm going to click 2D. Yeah. And so now we have this game. And it's a fully fleshed, realized video game. Let's run it. Or let's save it first, I guess. So we'll save this. This is our main scene. We'll save it as main.tsn. So just a quick explanation on scenes. The scene is basically like what you run when you want to play the game. And so this .tscn extension means that this is like a scene file. So we'll save this as the main scene, and we'll run it. Oh yeah, so we have to select the main scene that we want to run, because you could have multiple scenes. So you want to select the main scene that will run every time you hit builds or Command B. And this is our game. Very exciting. Yeah, so just recap. I just hit this button basically, or I hit Command B to play the project. Okay. Okay, so now if we go back to the image, so I have this idea of a bird, right? So I want this bird. And in Godot, everything is a node. Your basic building block is a node. So we have to figure out how to turn this idea into a bunch of nodes. That's like the basic problem, right? Godot knows things. There's two important concepts to know about Godot. There are nodes and scenes. And nodes are like the basic building block, right? So like everything is a node. Like this bird is a node. This building is a node. This building is also a node. The sky is also a node, probably. If there's like music playing, that is also controlled by a node. It's like, if you're familiar with Unity, it's like a game object in Unity is the basic analog. So nodes, a bunch of nodes together, they are contained in a scene. And so if this is like a bird node, oops, let's not go there. I promise this is worth it. I'll make things a lot clearer. So if this is a bird node, and then we have like a building node, this would all be contained within like a scene. So our like main.tsn. A scene file basically just describes the nodes that are in it. And so then when you actually run the game, what all you're doing is like basically reading the scene file, and then it's called like instancing it. So you're basically saying, okay, all the nodes in your in this scene file, I want you to start them running and do it. The way I think about it, of like the relationship between scenes and nodes, is this like metaphor of like sheet music and the actual music, which is like a metaphor used for like code and executables. It's basically the same thing. It's like if the scene file is sheet music, then the actual game that it just when you actually play the game is like the actual music that is produced by like a musician playing that sheet music. So the sheet music isn't a game by itself. It needs like an engine or like a musician to actually play it. Yeah, I know that this is like maybe too abstract, but I think start thinking about this. It'll make some more sense later. Okay. So like in this case, we have a scene and it has just this one node 2D that's not doing anything, right? So when we play it, it's not doing anything, or it's doing exactly what we told it to do, which was nothing. But if we want to make it more interesting, then we will add in this main scene. Let's add a bird node. So I'll rename this to root, and then I can add child node. So these are all the different types of nodes. Since we're working in these are all like 3D nodes, right? Things in like space. These are more like UI nodes, and these are like 2D nodes. So usually if you're making a 2D game, you use like a combination of these like 2D nodes and these UI nodes, because they're also like 2D nodes. But all of them have different things that they do, right? If we want a sprite, then we'll use like an animated sprite node or a other sprite node. If you don't know what your thing is gonna be, if you don't know what node you need, you can just use the basic node 2D node. It doesn't do anything, but it also just like can let you do whatever you want. I know that from making this game before that like what we want right now for this bird is a kinematic body 2D. I'm not going to explain what this node does right now. I'm just going to call it bird. And I'm going to also give it a child, another node, right, of animated sprite, type animated sprite. So basically, what I've done is in our main scene, here, let's make this smaller. We have the root node, and then we have the bird node. And then if we zoom in on this bird node, oops, that's not what I want. We can start to think about like what does this bird need, and one of the things that it needs is like a sprite because we want to see it. To do that, I'll call this anim. So all these, I always rename things to like lowercase short names because it's easier for coding reasons. But I mean, you can name it whatever you want. Okay. Right. So this animation node needs the actual sprites and the frames that it needs to animate. So you go over here to the right to the inspector, where you can see like in more detail what is happening with this. Like you can notice if you select different nodes, this inspector will show different things. It's sort of letting you see in more detail different things about that node, and also letting you edit it too. So for example, this one doesn't have a frames property, so it doesn't know what it actually wants to animate. So we click on here, we make a new one, we click on that, and now we have these animations, and you can edit this. You can just drag and drop sprites, And I've already made some sprites, so I'll just get them. Where are they? I think they're in. Yeah. Okay. Right. Okay. Nice. And so we can just put these frames into here. Oh, they're really blurry. Oh, really quickly. So they're really blurry because they're really small, and there's like automatic anti-aliasing that's happening. So I'm not going to explain this too much, but we can change the import settings here and turn off anti-aliasing so that they're nice and sharp. So that's good. And now this animation, if we play it, we should be able to see this animation. I don't know where it is. Yeah, it's there. It's very small. It's a speck, but it's doing things. So that's pretty cool. Okay. Obviously, this is like too small. So there's like a couple things we can do. We can either make the actual sprite bigger, or we can make this game smaller. And because like it'll make things easier in general, I'm just gonna make the game smaller. To do that, we go to project settings, and in all these settings, you can see here that the width and the height of the project is 1024 by 600 pixels. This is also known as like the native resolution. This is like what the project like builds to, right? So this window is 1024 by 600, like 1024 on the side, 600 tall. We are going to make that way smaller. We'll do 56. Yeah. And then try to build that. Hooray! So it's tiny, and it's off screen. Let's put it here. Okay, yeah, and so now it did what we told it to do. It made a tiny little game. Obviously, this is too small for me to play also comfortably. I mean, it could be interesting, but I think I want it to be easier to play. So what we can do is, like, if we take this and we try to stretch it out, you know, it doesn't really change anything. But what we can do is change the settings so that when we do stretch it, it'll scale. And so these are like the magic settings. There's like, you know, there are good reasons for why this works. I don't know what they are necessarily, but I just know that doing these two settings make it so that when you make a game like this, you can stretch it out. Yeah, this is actually one of the cool things about Godot is that, like, actually wait, the last thing is, because I don't want to keep having to stretch it out, I'm going to set some test width and test height so that it will automatically stretch it out every time I build the game. So this times, we'll make it 4x, 4 times bigger than usual. So it would be like, I think 1024 again, yeah. And then, okay. Yeah, okay, cool. So now we have like a nice resolution, yeah. This is like, the last like 10 minutes have been basically only applicable if you like want to make a tiny little pixel art game. Which is totally my jam. But one of the things about Godot that's really nice actually is that like it's way easier to make a to do these kinds of like resolution controls. I think it feels a lot more straightforward to me than when I use Unity. Yeah. Anyway, okay. So we have a little bird and it's flapping. So if we go back to, okay, let me close out of these. Okay. So that's basically like the loop. That's going to be like the rest of the stream. It's this process of I look at this image that I want or the one I have in my head, and I try to like add a tiny thing to get it closer to that image. So the next thing, I guess, is I want it to, right now we're just, I was imagining that it would move forward. So I'm going to try to make the bird move forward. So now that we want actual movement, I think it's a good time to do our first script. Also, I know that this might bother people. I'm not going to deal with it for like another like 20 minutes, so hopefully it's not too bad. But okay, so talking about this yellow triangle, it's like sort of annoying, but okay. Okay, so what we want to do is we want to move this bird to the right at a constant velocity, right? Okay. So this is welcome to GD script. A few interesting things is every node has this function underscore ready and also this function underscore process. Ready is called whenever a node enters a scene, and process is called on every subsequent frame. So when a scene is instantiated, let's write that right now. Instantiated. When a scene is instantiated, so basically at the beginning of the game, this ready is called, and then every frame afterwards process is called. And so what we want to do is move the bird to the right. So we will do, there's this function that Kinematic Body 2D has that's called move local x. And so you give this a number and it will move it that much over to the right. There is an interesting thing to note is that there's this delta here that you usually want to use to move things. Like you want to multiply it by the delta because the delta is the time that has elapsed between frames. But we move local x is kind of this like unique function that doesn't use delta. That uses delta under the hood, so you don't need to use it, or you're not supposed to use it. Kind of strange, but yeah. So we'll compile the game, and now our bird is moving to the right. It's a little bit too fast, I think. Oh wait, that's the wrong way. It's flying. Okay. Okay. Okay, so what I don't like about this right now is that it's going to the right and it's going off screen, and we don't know where it went, and that's sad. So what I'm going to do is add a camera to follow the bird. And so cameras are pretty complicated. Like, you can do some pretty wacky things with them, but what we're going to do is pretty simple. There's this trick where you can just make the camera a child of one of the objects, and you click current, and the camera will now follow that object everywhere. It's a little offset right now, so let's get rid of this. Yeah, okay. So it's perfectly centered on the bird, and now when we compile, it'll follow the bird. So the bird is moving, theoretically, to the right, and the camera is following it. It's hard to tell if it really is moving because there's no frame reference, but yeah, that's the idea. Okay. Okay, so go back to our image. What do I want next? I think I want to add this this blue sky, right? And so now that we have this hierarchy going, we have this main scene, and we have this bird, and we have in that we have the animation and the camera following the bird. And so now we want to add the sky, but the question is, do we add it at the same level as the bird, or do we add it like underneath the bird? And so this is kind of like I'll stop here and sort of like talk about like my thought process, because it's a little bit tricky, but it's like at least interesting to talk about. So get out of here. So right now we have the root, we have the bird, and the bird has its own children, right? There's in the Godot documentation, there's this idea that when you're making a game and you're trying to figure out how to structure your game, that you should think of your game like a house. And you have, if your game is a house with rooms, you have like the bedroom, another bedroom, like living room, kitchen. That if your house is like the scene, then each of these rooms is like a node, and then if you have like like a table here, and chairs, you would have something like, let's get rid of this too. You'd have like the house, root node, and then you would have all these children that are rooms. So this would be like the root, and then you would have like bedroom, another bedroom, kitchen, then like living room, right? And then in each of these rooms you would have like a chair and a table, for example. But the idea is that like, okay, chair, table, bedroom, yeah, and then these guys have like other nodes going off of them. But like the design like philosophy is that if you see this house at a glance, the first thing you see is just like the house, right? So at first you just see like the house, the main scene, and then when you dig a little deeper, you realize, okay, there are rooms. And so like at one level of like detail, you have like all the rooms, right? So these are all at like the first level after the root. And then in those rooms, you have like these, you have a chair and a table, but you wouldn't have like the chair be like a child of this root, or the table be a child of this root at the same level as the rooms. It's sort of like every room has the objects that are in it as its children. Like you can imagine that, like, you know, if we took off this, cut off this bedroom, right? So that's like that's like this bedroom. We could just like take that bedroom and put it here with like the same chair and table, and it would still like make sense, right? Like it's sort of like the self-contained thing. So that's like the idea of like how to organize things in general. And so that being said, if we apply that, okay, let's do another thing. If we apply that to like our scene, the first thing that I see is like the bird, and I see the sky, and I see the buildings. So in my head, what makes sense is to have like the bird and sky and buildings all on the same level. So I'm going to add the sky basically just in back of the bird. Okay. Actually, this guy's going to be a sprite, right? Because it's just the background sprite. So, oops, that's not what I want. I want to remove you. Okay. So we add a sprite type, which we haven't done yet. And sprite is similar to animated sprite, except that instead of instead of having well, it's not animated, so instead of having sprite frames, it takes just a texture resource. And all you have to do to satisfy that is drag it over, and boom, you have a sky. So I just made the sky with a sprite node, and then dragged in my PNG into the texture spot. And so now we can position it, I guess like over here. Oops. There's two problems. First, the bird is behind it, and also it's moving away from it. So we can put the bird in front of it. But it still has a problem that it's like moving away from the sky. And so, okay, and this is interesting because one thing we could do is we could just write some code so that the sky moves with the bird. But another thing we can do is just make it a child of the bird. Oh no, can I not reprint? Oh wait, this guy. Okay. And this breaks like the house rule, right? Because it's weird that like the bird now owns this sky. Like that shouldn't be like in my mind when I'm imagining this scene, like the bird and the sky are sort of like part of the same scene, and it's not like the bird like carries this, like the sky isn't like a smaller thing than the bird. Yeah, but this is like a really nice trick, and it makes things really easy, and unless it like breaks something else, like I think this is like fine. So basically what I'm trying to say is that like I think there's like good design philosophies for how to do things, but also like a lot of times it's just like whatever works, man. Okay, so now we have a bird flying in the sky. That's good. Okay, what's the next thing we want to do? I guess we have a bird. I guess we could make, I was kind of thinking the bird would be controllable, like you could flap it by like pressing the space bar or something, and that would like bounce up and down. So that's one thing. Another thing is the buildings. I think that both are going to be a little bit tricky, so I think I'm just going to go, we'll do buildings first. Try to get some buildings in here. Yeah. So we will add a, so since, I'm imagining that they're all, like if this scene is a room or as a house, then you have like the bird room and then all the building rooms too. So I'm at the same level as the bird. It's just going to be a sprite. Oh, no. Eventually I want to do collisions, so I'm going to make it a static body 2D, which I won't explain just yet, but basically it's a node that will let us do physics and collision interactions with the bird later on. But that is, I only know that because I've like made this game already to prepare for it. I think if I was making this game like from scratch, I think the first time I did it, I just did like plain no 2Ds, but I don't feel like changing it later. So we're going to do this. We're going to pretend like we're smarter than we are. Okay, so this is a building. And then a building is going to have a sprite with it. Right? Like we have to have a visual component to it. So we'll add another child and we'll make it a sprite. Oh my god. Okay. And then we'll do the same thing we did with the sky. We'll just add the building texture from here. And we'll place it there. Aha. So now we are flying. Also, I just noticed it's kind of blurry, so I think I can use the filter. I need to re-import these also. Okay. So, okay, nice. Also, why is the sky offset a little bit? This little thing right here? Yeah, it is. Okay, weird. It's still there. Okay, I won't worry about it for now. Okay, nice. So we got a building. So one building is cool, but I was sort of imagining that there would be like an infinite number of buildings, or just like you would just fly and you'd keep having buildings pop up, right? And so I think that maybe the way to do it is have a timer that goes off. So like every couple seconds, we spawn a new building like off screen, like in front, and so we just keep spawning buildings. So a good, interesting question to ask right now is like, okay, so do we put that? So we want a script, right? And we want to code something that will have that will basically spawn buildings. So do you want to put that in the building script or in this main script? And I think my preference is to put it in the main script. So I think it makes more sense to have like the main thing control the stuff underneath it, instead of like having this thing try to spawn itself. So yeah. So the first thing we need is a timer that will every few seconds will do something. And so in Godot we have this useful timer object that we can just instantiate. Let me find my notes. Okay. I'm just going to write some code and explain it after I'm done. So like, make a new timer, set the wait time to like 2 seconds, add it to ourselves, and then we start it. Okay. And then also we will connect the signal from it to timeout. Okay. Okay, so let me explain this, what I just wrote. So this line of code makes a new timer. Just instantiates a new, it makes a new timer from this timer, like built-in class to Godot. And then this line makes it so that the timer goes off every 2 seconds. So now like every 2 seconds, like 1, 2, it goes off. 1, 2, it goes off. This, I'll skip this line for now. This line adds it to the, so add child adds whatever is in the argument to whatever is running the script. So it'll add it to this root node. And actually, if we run it, you'll see in this remote instance is like the actual instance of the game that's like being played right now. So like this is actually like the values here and stuff are like what's happening in this game right here. But you can see that like it added this timer. It has a weird name because we didn't give it a good name, so it makes an automatic name and it's kind of weird. But that is like the timer that's being added. Okay, let's go back to the code. Okay, and then this line just sets it off, sets it going. Okay, so this line is the interesting bit. So there are these things in Godot. There's this feature called signals, and it's very, I think, useful for certain things, like along the lines of like asynchronous execution. It's like they're pretty analogous to like events or notifications, or sort of like basically, yeah, events are things that happen at some time, and then you want a certain other set of things to happen when that event happens. And the way that signals are structured in Godot is just more JS Paint. Oh, geez. Go. So if you have like a node, you can imagine a node. So let's make, this is the timer node. Nodes can come with these things called signals. And so this timer has, for example, a timeout signal. And this timeout signal is called every time that it times out, right? So in this case, it would be called every 2 seconds, right? And so this timer node, which is of type timer, has this timeout signal. And then we have our node, which is, in this case, the root node. Oh, wait, Twitch is saying things. Okay. Yeah, they're callbacks. Yes, they're basically callbacks. Yeah. Signals are basically callbacks. Yeah, so this is the root node. And what we do here, when we connect them together, is basically saying that, okay, I'm going to connect this to my thing, and I'm going to, whenever it times out, I'm going to call this on timer timeout function, which we will actually define as an actual function. Do pass for now. Right. Okay. And so then this lovely picture I've drawn, this would be the on timer timeout. Yeah. And so it's nice because what I like about signals in Godot is that you can have these signals and they can be totally unconnected to anything, and you can just send that notification and it does nothing. Or you can connect them and they'll do things. It's nice and sort of, it lets you fit together nodes in certain ways and put them together like Legos in really nice and elegant ways. You hook up all the signals and things sometimes just work. Yeah. But yeah, they're basically callbacks. Okay. Right. So what do we want to do? Let's test that it works. Okay, so I guess I'll go until, yeah, so every 2 seconds it fires and we print it out. So that means this timer every 2 seconds fires this timeout, and then our root node runs this function, and we print 2 seconds. I'm just looking at my time, so it's 4:50. So I think I'll go until 5:30. That should give us enough time to finish this thing, barely. Okay, cool. Okay, so what we want to do here is actually spawn a new building. And so in this case, what we're going to do is we go back to, one thing we could do maybe is we have this building variable, right? So one thing we could do is make a duplicate of it, which I tried. Right, and then just spawn it later. But the problem is that this duplicate function doesn't work as the way it is advertised. I think I showed that issue in the beginning when I was talking about it. This is one of those things where it's there's a bug with it, and it's not looks like they're not going to fix it anytime soon, and so find another way to do it. And so the actual good way of making, creating a new object out of an object is by first turning it into a scene by doing save branch as scene. So we save it as this building scene now. And now we have not just a building node, but a building scene. And if we open that up, you'll see that it's just the building node, right? So if we go to like the metaphor of the house again, this is sort of the same idea as taking this bedroom and like making just like a bedroom scene. And so what that allows us to do is like, if you got this house and you're like, you know what, I actually want 10 bedrooms because I want to sleep in a different place every night of the week. And so you can, from this like bedroom recipe, or like from like the sheet music for it, you can create 10 bedrooms, right? So because this is just like the recipe of how to make it, you can instantiate and make like actual like living nodes from that bedroom. So that's what we're going to do. Okay, so in here, the first step is to get my notes, is to get the scene. And the way we get the scene is we load it from our resources. So what this is doing is getting the scene file from our resources and then loading it into the current scene. So now we have this like scene object, or what's called a packed scene, right? It's like it's basically it's this like recipe, but we can't really do anything with the recipe or with the sheet music, right? And to actually make the thing from that sheet music, make the node from that scene, we do scene.instance. Wait, is instance or instantiate? Wait, hold on. Reload it. Instance. Okay. That should work. Let me double check. I think this should give us like an object. Yeah. Okay. Cool. And all of them are like, they have different IDs. So every time we call instance, we create a new static body 2D or like the building, right? Okay. And now that we have that building, we want to actually add it to the scene and put it where we want it to put it. So we will add it to ourselves because we're the root, so we'll add it to this, and then we'll put it like in front of us. We'll put it like off screen. So like if this is the game, we want to put it like over here, so then it like slides in to the screen. So it'll be, we'll get bird position, which would be, let's get just like the verb, the x1, which is get position. No, it should just be this one. Yeah. And then we'll put this at where our bird is, but plus a screen's width, which is, what is it, 256? 256. And then we'll make the height like middle of the screen. So 72. Okay. Did it spawn it? No. I don't think so. Do I have a bug? $72. Let me, here, before I explain what this is, let me just debug this. Okay, so we're spawning the buildings. Actually, maybe this is a good time to explain how to debug stuff. So basically, I'm expecting all these buildings to like be spawned and ready like to the right, but they're not. And so I want to know like why, like where are they? And so if we go to the remote tab here, this is like the actual game that's running, right? So local is like when you're like editing stuff and designing things, and then this is like the real deal. Sort of like the play tab in Unity. So now so we're seeing that we're spawning all these buildings, but for some reason we can't see them. So I want to know, where are you? Position 479. Are we moving too fast? This seems like they should be. Are they behind this guy maybe? Hold on, maybe turn off this guy for a second. So you can do this to sort of like occlude it for a second. No, they're just not there. This is not good. Okay. Let me think. Anyone knows what this bug is? Get position. Yeah, so it's like it's getting the right. Let's do some printfs. It seems to be getting good bird position. Wait, what? Oh, that's fine. Okay. And then, yeah. Especially this one. Let's try. What if we just spawn them on the bird? Oh wait, is 70? Is this the weird thing? What if we just put them at 0? No. Let's try. Oh wait. So maybe that was it. Okay, that's a good height too. So let's keep it there. Wait, 72 should be. That's weird. I don't understand. Wait, what happens if I put it at? I don't understand why 72 wasn't working. What to do if I do 10? So in Godot, the y direction goes positive downwards. So like this is, the top of the screen is 0 and the bottom is, I think, is like 144, because that's as tall as we are. So 0 should put it way up high. Yeah, I'm still not sure. Whatever, this works for now. Positioning things relatively is tricky and weird. Okay, I'm going to put it back to 0. Okay, sure. Turn the sky back on. Okay, nice. So now we have infinite rent strike buildings. Okay, let's make them a little bit closer together, actually. And then we'll also I was thinking like maybe we should just duplicate these, but I think that it's fine for now. Okay. So the next thing is I was kind of imagining that the buildings would be like sort of varied in height. So someone would be like this tall, someone would be this tall. So let's do that. Let's get those. Let's vary their heights. Where are we at? 501? Okay. No. Oh. Okay. So we're going to vary the heights. And the way we'll do that is we can set 0 is like a good like average point. So maybe we want to put it up or down by like 10 or 20. So we'll do var height equals, and then we'll get random integer. Oh wait, sorry. No, I'll do this first. We'll get a random integer, and then we'll mod it by what variation we want? 20, I guess. Yeah, so we'll do this. Oh, that takes a lot. Oh, that's not much. I guess it's kind of variation. We'll do more. So what this is doing is we're taking, this returns a random integer from like 0 to max int. It can be like any number. So what we do is just mod it by 40, which is like dividing it by 40 and taking the remainder. So now we just get a random number between 0 and 39 or 40. There's no like cleaner way to get random integers in Godot. This is just kind of the way you do it. Nice. So we're getting some variation. Kind of want them a little taller. So we'll add like 20. I'm gonna get water really quick. Wait, what? Oh, right, because it goes down. It goes down. It goes down. It goes down. So let's do. But then why was whatever? Let's do. Still not much like variation, I guess. Maybe that's just the way it is. That's fine. Okay, we'll keep it like that for now. I'm going to get water because I'm parched before we continue. Okay, got my water. What do I want to do? Okay, so we got these buildings going, and that's satisfying. That's nice. The next thing I want, one thing that would be cool is to have more than one type of building. Maybe say something else than rent strike, although it's pretty good though. But the other thing is there's a car alarm going on right now. The other thing that we could do is give some control to the bird so the player can actually do. So that's actually a video game and not just a art movie. Okay, let's do. So let's do that. Let's work on the. Let's try to give the player some control over the bird, some inputs. So the first thing we'll do is give the bird some gravity. My notes. Gravity. Okay. So, okay. So, I think in order to simulate gravity, we need to have this idea of like acceleration and velocity, and so we need to store the velocity so that we can accelerate every frame. If that makes sense. So like we'll make a new velocity variable. And then every frame, oops, we will add -1 or 1 to it. The method vector isn't declared in the current class of 2. And then we'll also move it cy velocity.x. So every frame we should add 1 to the velocity, and so it'll continuously just get faster and faster and accelerate downwards. So that's gravity. Actually, let's run it. Whoa. Why is the camera not following it though? Oh, because it can't keep up? That's funny. Okay. Yeah, so we just sink down fast. I think the camera's not keeping up to how fast it is. Yeah, I don't want it to fall that fast. I do want it to like kind of have gravity and accelerate, but I don't want it to like get too fast. So let's do like a max fall speed. I'll call it, I don't know, 0.4 because I think that could be nice. Yeah, and then we'll also just make for now a gravity constant. 0.08, and then so we'll add gravity every time. These are like magic constants that I think should be good, but we'll probably still want to tweak them. But okay, max fall speed. So if we want to clamp it, so like if we don't want it to get any bigger, hold on, fall speed. Right, we don't want to get any bigger than than max fall speed. What? From nil to float. Nice. So now it follows a nice little chill speed. Okay. Yeah, so this is basically clamping and limiting the velocity so it can never get higher than this. So if it ever tries to get higher than this, it just clamps it back down to this speed. Okay. Okay, so now that it's falling, let's do something to try to get input so that we can actually control it. So let me explain how input works in Godot. So the main way that I do input is this input class has this action just pressed, just released, and action pressed. And so these are all correspond to like basically keys that either this is fired like action just pressed, which is the one I usually use, is this is true when that key is pushed only like for the first time on this frame. Action pressed, yeah, so action pressed is true whenever that key is held down, but for this case I just want action pressed, and we'll do it, call it fly, the fly action. It's nice because instead of having to have a key, we can just define some like abstract thing like fly, and then in the project settings under input map we can create an action, right? So these are all different actions, and we want to create our own action, which is fly, and we want to give it the keys. So spacebar works, and also the up arrow. Nice. Okay, cool. And then in the code, when fly is pressed, we go velocity. Looking at my notes. Oh yeah. We'll do like -2 to set it up. Yeah, nice. So we can keep hitting up, and we'll keep flapping and going up. Now we got a real video game. Cool. Okay. Oh wait, but now we're not going sideways anymore. That's not good. Oh, because we turned this. So let's do one. Nice. I don't like this jitter on the bottom. I don't know what's happening. I don't know. Okay. Yeah, I'm not going to try to debug that. That's just going to be a quirk of the game. Okay, so wait. Let's do. So now we got that. That's an input. Yes, run this again. There it is. Okay. Nice. So now we're a bird flying across rooftops. Cool. Okay, and then the thing that I really wanted that would make me very happy we could do is have it so that the bird collides with these buildings, or at least like sits on these buildings. And so to do that, we're going to use, finally, these like kinematic and static physics 2D objects that we've created at the beginning but never actually took advantage of. And we're going to use some built-in things from Godot to do some interesting fancy things. So the first thing is we're going to take care of this finally. And so what this says is that we want, this is a kinematic 2D object, right? And so it's a physics object. Here, let's do a quick JS paint. Okay, so we have this like kinematic 2D object, right? This is like our bird. Inside buildings. Oops. This is like our bird. And these are our buildings. And the idea is that like Godot has an internally built-in physics engine, a 2D physics engine that you can use so that you can detect when this like object crashes into like these buildings. But to do that, you need to define this box, you need to provide this object. And so it's saying that we have this kinematic 2D object, but we're not providing a box, a collision shape. So consider adding a collision shape 2D. Okay. So we'll call it collision shape. And then this gives us another yellow triangle, and it wants us to create a shape resource for it. So we'll go in here and create a new shape resource, and then we look at the bird up close. We can see that there's this like rectangle around it, and we can select it and select the collision shape, and then select it again to like modify it, right? So let's fit it closer to the bird. Yeah, and save that. Okay, cool. And we'll do the same thing with this building. We'll actually do it in here, in the building scene, so we're gonna modify the building, but not. So this is just the building that's like there at the beginning. But we're gonna go and modify the building scene because this is the thing that's read from when we create new buildings. I have like 10 minutes left. I don't know. I feel like maybe I'll get this collision stuff working, and that'll be it. That'll be the stream. Okay. So yeah, this collision shape. I guess I'll point out that there's like all these different kinds of shapes you can use, and I prefer, or we don't need anything more complicated than this rectangle shape. It's the best shape. It's very nice and simple. So the extensor over there, oh, maybe that's why the position is weird, because there's this like weird offset with it. Oh, wait. Oh, because the sprite is maybe offset. Oh, this is why the position, oh, this is going to screw with the positioning. It's okay. Okay. Let's change. So like this sprite was offset from the middle, and so when we instantiated it, here, let me put it right. But when we instantiated it in this code over here, That's why it was like not the right height because like it had the offset. Yes, boom, boom. So now this will probably be like, I don't know, I have to offset it by like 50 or something. Oh no, this just screwed everything up. Wait, hold up, let's think about it. Let's do this. 50 plus, I mean that should be fine. Because if it's now if it's actually centered, I don't know why that one. Oh, because now, okay. Cool. All right. But now, right, now, since we changed this like scene, the node that scene inherits from, or that instantiated from this building, is automatically changed too, and so now it got like put up there. But we can just move it down to there, so nice. Also, maybe it's a good time to just like make a bunch of these manually. Let's do extents first. Okay, wait. Yeah, so we'll create a nice little, so this is like the collider, right? And so this is just matching the sprite to the collider. Okay. Yeah, I'll just do this bird. I'll get the bird to like sit on the building, and that'll be the stream. Okay. Nice. Okay, cool. There'll probably be some overlap, but whatever. Doesn't matter. Okay. Cool. I think it's bouncing. I don't want to know. Okay. Okay, so okay. So now that we added the colliders, we can actually use them. So there is this new function that we're going to use called physics process. Here, called physics process. And it's similar to process, but instead of being run every frame, it's called every like physics simulation tick, it's called. So a frame is like dependent on what is shown on screen. Like every frame is like really, it's like every time there's a new frame for like animating things, that's a frame. But physics process is sort of independent of the frame rate. It's more tied to the physics simulation, which has its own like speed. So like sometimes that simulation might tick or might do like calculations like, 3, I don't know, 10, I don't know what the number is, but like, a bunch of times between every frame, or maybe there'll be a bunch of frames between physics simulation ticks. I'm not sure. But yeah, so what's important is that using physics process is what lets us do physics, use the internal physics engine for collisions. And the magic function that we're going to use with it is called move and slide. And we'll just give it our velocity. And also this, which I'll explain in a second. Vector isn't declared in the current scope velocity. I thought it was. Oh, am I in the wrong? Yeah, I'm in the wrong. I'm in the wrong script. Okay. Let's go here. Okay, so I was in the main script instead of the bird script. Okay, nice. And so basically, like, move and slide, what it does is attempts to move this kinematic body 2D object, but if it tries to move it in a certain direction, right? So let's say it's going like this way. And so this is like some like physics 101, I guess. But any 2D vector can be split into its x and y parts, right? Like our velocity has the x and y parts, right? So there's velocity.x and velocity.y. And what move and slide does is if this box collides with another box in one of those directions, it will just like stop it from moving in that direction, right? So like the velocity is still telling it to move, but it's just not going to. But it won't stop it in this other direction. So that's why it's called move and slide. So it tries to move, and if it can't, then it will slide across. And so that's cool. But yeah, actually, so now let's yeah, let me switch over everything to this to use move and slide now. So instead of using move local, we're using move and slide. I think this should work. Oh my god, it's so slow. Let's do times 100. Maybe that's the thing. Oh, that was it. Yeah, okay, nice. Yeah, and so now when we hit buildings, actually it's 5:30 now. Yeah, nice. Okay, I think I'll call it. I think I'll call it there. I think it's a good spot before things get too wacky. So this is a very non-buggy, nice, fully fleshed out game in Godot. Yeah, I guess I'll stick around and answer any questions if anyone's still here and has any questions about anything. But if not, then thank you for joining me. This was a good time. I hope that you learned something about using Godot, making things in Godot. Yeah, thank you. I'll stick around for questions for a bit. Particular type of game that Godot is best at making? That's a good question. Yeah, so the question is there a particular type of game that Godot is best at making? Yeah, yay, Rent Strike, true. I think I don't know, so I don't know anything about 3D, first of all, so I guess I can only speak to 2D things. I think that actually I think that for this sort of game, so like a really small game that wants to do like physics, like little like 2D physics stuff, or even not the physics stuff, as long as like it's small and not complicated, and you don't need to have like a dialogue system, I think that it's good at that. Once you start doing like anything that's too sort of strange and and not like you know like a mechanics game, like the problem is there's just not a lot of like support for like assets or plugins to do that kind of stuff. And you start to run into I think at one point, like at some point, like if you're trying to do something too something like complicated, it's probably not conducive to do that thing in Unity or anything else. Like it's like the same thing, the same difficulty, but I think that in particular, Godot is good at like making games that, they're about like this size, I guess, or like no, not this size, but like this sort of idea, like a simple games, but that can do something like interesting mechanically, right? It's like not. I'm just trying to think about like why, like what advantages it has over like Pico 8, and I guess it just doesn't have like all those like constraints, like all the artificial constraints. But yeah, I don't know. Cool. Okay, cool. I think I'll just wrap this up. All right, thanks everyone. Thanks for tuning in. I'm gonna stop this stream.